The tropical heat hung heavy over the captured airfield somewhere in the South Pacific, the year 1943. A team of American intelligence officers and engineers stood around the twisted wreckage of a Japanese bomber, their uniforms soaked with sweat, their faces etched with a mixture of curiosity and disbelief. They had been examining captured enemy aircraft for months now, piecing together the technological secrets of their adversaries, learning the strengths and weaknesses that could mean the difference between victory and defeat, between life and death, for American pilots fighting their way across the Pacific. But nothing had prepared them for what they were about to discover inside this particular aircraft. The bomber in question was the Mitsubishi G4M, though American intelligence had given it a different name. Following the Allied convention of assigning female names to enemy bombers and male names to fighters, this sleek, cigar-shaped aircraft had been christened Betty, after a well-endowed nurse that Technical Sergeant Francis Williams knew back in the States. The naming seemed almost frivolous now, standing there in the oppressive heat, surrounded by the metallic stench of aviation fuel and cordite, examining an aircraft that had terrorized Allied forces across the Pacific for nearly 2 years. The Betty had earned a fearsome reputation in the opening months of the Pacific War. These twin-engine bombers had ranged across impossible distances, appearing suddenly over targets from the Philippines to Australia, from the Aleutian Islands to the Indian Ocean. They had participated in the devastating attack on Clark Field in the Philippines on December 8, 1941, obliterating American air power on the ground before most pilots could even reach their aircraft. Just 2 days later, Betty bombers armed with torpedoes had achieved what many military experts had deemed impossible, sinking the British battleship HMS Prince of Wales and the battlecruiser HMS Repulse off the coast of Malaya. It was the first time in history that capital ships actively defending themselves had been sunk exclusively by air power while at sea. The age of the battleship, it seemed, had ended in a matter of hours, replaced by the age of the bomber and the aircraft carrier. The American intelligence team had been tasked with understanding why the Betty was so effective, how it achieved its remarkable range, what made it such a formidable weapon in the hands of the Imperial Japanese Navy. They had recovered several examples from various battlefields across the Pacific, each one providing pieces of the puzzle. Some had been shot down and crashed relatively intact. Others had been captured on airfields overrun by advancing Allied forces. Each aircraft told a story, revealed secrets, offered insights that could save American lives. But as the engineers began their systematic examination of this particular Betty, cutting through the aluminum skin, tracing fuel lines, examining the wing structure, they encountered something that stopped them cold, something that made no sense according to everything they knew about military aircraft design, something that would fundamentally change how American pilots fought the air war over the Pacific. The wings of the Betty bomber were essentially giant fuel tanks. The entire structure between the wing spars had been sealed and converted into fuel storage, a design known as a wet wing. This wasn't unusual in itself. Several Allied aircraft employed similar designs to maximize fuel capacity. The Americans had seen this before. What shocked them What made the senior engineer call over his colleagues with an urgency bordering on alarm was what the Betty's wings didn't have. There was no self-sealing system, no protective rubber bladder, no layers of vulcanized and untreated rubber that could swell and seal punctures, no armor plating around the tanks. The fuel simply sloshed around inside the aluminum wing structure, contained only by the outer skin of the aircraft and the wing's internal framework. A single bullet, a single piece of shrapnel, and fuel would pour freely from the wound, mixing with air to create an explosive vapor cloud just waiting for a spark. "There has to be something we're missing," one engineer said, running his hand along the interior of the wing cavity. "Maybe they have a different system, something we haven't seen before." But there was nothing. The examination continued for hours, then days. They brought in more specialists. They examined multiple captured Bettys. They cross-referenced with intelligence reports from other technical air intelligence units scattered across the Pacific theater. The conclusion was inescapable and shocking. The Japanese had deliberately designed their most important naval bomber, an aircraft that would be sent against heavily defended targets bristling with anti-aircraft guns and fighter protection, without any fuel tank protection whatsoever. "Do they not know about self-sealing tanks?" a younger officer asked, genuinely confused. "Or do they just not care about their crews?" The question hung in the humid air, unanswered for the moment, but it would echo through the halls of American military intelligence for months to come. To understand the answer, to truly comprehend the design philosophy that had produced the Betty bomber, you had to go back to September 1937, to a small office in the Nagoya works of the Mitsubishi Aircraft Company, where a brilliant engineer named Kiro Honjo sat staring at a set of requirements that seemed, on the face of it, completely impossible. Kiro Honjo was no stranger to difficult assignments. He had studied bomber design at the Junkers Works in Germany, learning from some of the most advanced aeronautical engineers in the world. He had designed the G4M Nell bomber, which had already proven itself over the skies of China with unprecedented range and performance. He was, by any measure, one of Japan's finest aircraft designers, a man who understood the delicate balance of compromises that went into every successful aircraft. But even he was taken aback by what the Imperial Japanese Navy was asking for. The specifications, officially designated as the 12-Shear attack bomber requirement, called for a twin-engine, land-based bomber that could fly at a top speed of 247 miles per hour, maintain a cruising altitude of 9,800 feet, and, most incredibly, achieve a range of 2,934 miles without any payload, or 2,300 miles while carrying an 1,800-pound torpedo or equivalent bomb load. To put this in perspective, that range requirement was more than double what most contemporary bombers could achieve. It was a range that would allow the aircraft to strike targets deep in China from bases in Japanese-controlled territory. A range that would enable attacks on the Philippines, on Malaya, on targets across the entire breadth of the Pacific Ocean from island bases. A range that represented Admiral Isoroku Yamamoto's vision of projecting Japanese naval power through long-range land-based aviation, circumventing the limitations placed on Japan's battle fleet by international treaties. Honjo understood immediately what the Navy was asking for and what it would cost. The specifications, as written, were unprecedented. No twin-engine bomber in the world could meet these requirements. Not the German Heinkel He 111. Not the American B-25 Mitchell. Not even close. To achieve this kind of range, he would need to maximize fuel capacity while minimizing weight in every possible way. Every pound mattered. Every ounce counted. The mathematics were brutal and unforgiving. He assembled his team, including Kushibe Shiro and Hikata Tetsuro, and they began working through the problems. They had one advantage. Mitsubishi had just developed a new engine, the Kase Radial, producing 1,530 horsepower. It was significantly more powerful than anything previously available, offering perhaps a 50% increase in power. But even with these new engines, meeting the Navy's requirements would require design choices that Honjo knew were dangerous. The bomber took shape on the drawing boards through 1938 and 1939. Honjo designed a wide, streamlined fuselage that was built in two halves to ease production, so wide that visiting German engineers from Heinkel expressed confusion when they saw the bulkhead, unable to believe it was for a twin-engine aircraft. The fuselage's cylindrical shape would eventually give the Betty its Japanese nickname, Hamaki, which meant cigar, a reference to its distinctive shape and, ominously, to its tendency to burn like one when hit. But it was the wing design that presented the greatest challenge and the greatest compromise. To achieve the required range, Honjo needed massive fuel capacity. His solution was elegant from an engineering standpoint and terrifying from a safety perspective. He designed the wings with integral fuel tanks between the main spar and a secondary spar forward of it, with the ends sealed by solid wing ribs. The surfaces of the wings themselves became the walls of the fuel containers, creating what was essentially a flying fuel tank with engines and a fuselage attached. The fuel capacity was enormous, over 4,580 liters, enough to take the Betty thousands of miles from its base. The problem was protection. Self-sealing fuel tank technology had been developing rapidly in the late 1930s, driven by the brutal lessons of the Spanish Civil War and the early months of World War II in Europe. The British had watched their pilots burned to death over France in 1940 and had responded by rushing self-sealing tanks and armor protection into production. The Germans had developed their own self-sealing systems, incorporating layers of vulcanized rubber, untreated natural rubber that could absorb fuel and swell to seal punctures, all wrapped in leather or fabric outer layers. The Americans were pouring resources into refining these systems, with companies like Goodyear, Firestone, B.F., Goodrich, and U.S. Rubber competing to develop the most effective designs. Honjo knew all of this. He understood the technology. He recognized the vulnerability he was creating. But the mathematics were inexorable. A self-sealing fuel tank system required approximately 1¼ inches of rubber layers, weighing roughly 660 pounds for the Betty's fuel capacity. That weight would have to come from somewhere. It would reduce fuel capacity by about 1/3, cutting the Betty's range to perhaps 2,000 miles loaded. It would increase the aircraft's weight, reducing speed and climb rate. The Navy's requirements couldn't be met with protected fuel tanks, not with the engines available. Not with the technology of 1939. Honjo made his choice. Actually, the Navy made the choice for him when they insisted on the range requirements and refused to compromise. The Betty would fly without self-sealing tanks, without armor protection for the crew, relying entirely on speed, range, and defensive armament to survive. It was a calculated gamble based on the assumption that the Betty would face limited opposition, that its speed and altitude would protect it, that its heavy defensive armament, including a 20-millimeter cannon in the tail, would deter attackers. And critically, it was based on a strategic assumption that would prove catastrophically wrong, that the war would be short, sharp, and victorious, with Japanese aircraft doing most of the shooting before the enemy could effectively respond. The first G4M prototype made its inaugural flight on October 23, 1939. Test pilot Katsuzo Shima taking the sleek bomber into the sky from an airfield near Nagoya. The aircraft had actually been transported to the airfield in pieces, stacked on 5 ox-drawn farm carts over unpaved roads, a scene that seemed to belong to a previous century rather than the dawn of the age of strategic bombing. But once assembled and airborne, the Betty performed beautifully. It met or exceeded all the Navy's specifications. It was fast, reaching speeds of 267 miles per hour. It handled well, and most importantly, it had the range, the precious range that the Navy demanded, that Admiral Yamamoto needed for his strategic vision. There was a brief diversion when the Navy, worried about the heavy losses suffered by unescorted G4M bombers over China, ordered the development of a heavy fighter variant called the G6M1, intended to serve as a wingtip escort, flying alongside bomber formations with enhanced armament. This experiment, like a similar American attempt with the B-17-based YB-40, proved a failure. The heavily armed variants were too heavy to keep up with bombers that had dropped their ordnance, and the project was abandoned. The original bomber design, the G4M1, went into production in April 1941. The first production models rolled off the assembly lines in the spring of 1941 and were immediately sent to units in French Indochina and Formosa, where crews began training with the new aircraft. The pilots and air crews were impressed. The Betty was comfortable, roomy, with space for the 7-man crew to move around during long missions. It was well armed with 4 7mm Type 92 machine guns in the nose, dorsal turret, and waist positions, plus that impressive 20mm Type 99 cannon in the tail, a heavier armament than most bombers of the era carried. It could carry a massive 1,890-pound Type 91 torpedo, the most accurate and powerful aerial torpedo in the world at that time, or an equivalent weight in bombs. The crews loved it. One pilot, years later, would recall his first impression of the Betty. It excited me as nothing else had ever done. Even on the ground, it had the cleanest lines I had ever seen in an airplane. It was a dream to fly. Everything seemed perfect. Everything seemed to validate the design choices that Honjo had made, the compromises that had seemed necessary to meet the Navy's requirements. But underneath that sleek aluminum skin, invisible to the crews who flew it, was a vulnerability that would turn the Betty into what American pilots would later call the flying lighter, the one-shot lighter, and most tellingly, the flying Zippo. The Japanese themselves would give it nicknames that reflected the same grim reality, though officially explained as references to its cigar-like shape, The crews knew better. They knew what happened when a Betty took fire. They would learn it in blood and flame over the atolls and islands of the Pacific. The Betty bomber entered combat for the first time on September 13, 1940, over mainland China. 27 Bettys, along with Mitsubishi C5Ms of the 1st Ringo Kokutai, departed from airfields in Taipei, Omura, and Jeju to attack targets in Hankow. They were escorted by 13 A6M0 fighters of the 12th Kokutai, led by Lieutenant Saburo Shindo, who would later become one of Japan's most famous aces. The mission was a success, demonstrating the Betty's ability to strike targets at unprecedented ranges while carrying significant bomb loads. Similar operations followed throughout 1940 and 1941 as Japan expanded its operations in China. The Betty proved its worth again and again, appearing suddenly over Chinese cities and military targets, dropping its bombs and disappearing before effective opposition could be mounted. Against limited Chinese air defenses and an air force equipped with obsolete aircraft, the Betty's lack of protection wasn't a significant liability. Chinese fighters rarely got close enough to exploit the vulnerability. Chinese anti-aircraft fire, while dangerous, wasn't accurate or concentrated enough to reliably hit the fast-moving bombers at altitude. The Japanese military leadership watched these operations with satisfaction. The Betty was performing exactly as designed, exactly as promised. Admiral Yamamoto's vision of long-range land-based aviation projecting Japanese power across vast distances was being validated in combat. Plans were already being drawn up for much more ambitious operations that would require the Betty's extraordinary range, operations that would determine the course of the war in the Pacific. When the war began with the attack on Pearl Harbor on December 7, 1941, Betty bombers were poised at airfields across Japanese-controlled territory, ready to strike targets thousands of miles away. On December 8th, flying from bases on Formosa, 107 Betty bombers crossed the Luzon Strait to attack American airfields in the Philippines. The attack was devastating. American air power in the Philippines was destroyed, most aircraft caught on the ground, the few that managed to get airborne quickly overwhelmed. The Bettys had performed perfectly, arriving exactly when expected, bombing with precision, and returning safely to base. But it was the next operation, just 2 days later, that would make the Betty legendary, and in a real sense, change naval warfare forever. On December 10, 1941, British naval forces, consisting of the battleship HMS Prince of Wales, the battlecruiser HMS Repulse, and 4 destroyers were steaming off the coast of Malaya, attempting to intercept Japanese invasion forces. The British ships were the most powerful naval force in Southeast Asian waters, a force that should have dominated any Japanese naval opposition. Admiral Tom Phillips, commanding the British squadron, knew the danger from air attack and had requested air cover. But the Royal Air Force had no fighters available. The few aircraft in the theater already overwhelmed by Japanese attacks on airfields across Malaya. When Japanese reconnaissance aircraft spotted the British squadron on the morning of December 10th, the Imperial Japanese Navy launched a massive airstrike from bases in Indochina. 85 bombers, including numerous G4M Bettys and older G3M Nells, took off and headed for the British ships. They found them at 11:00 in the morning, steaming through calm seas under clear skies, perfect conditions for bombing. The attack was methodical and devastating. The Bettys came in at different altitudes, some carrying bombs, others the deadly Type 91 torpedoes. The British ships maneuvered frantically, their anti-aircraft guns firing continuously, their gunners desperately trying to ward off the attacking aircraft. They managed to shoot down only 4 bombers. It wasn't enough, not nearly enough. The Prince of Wales took the first torpedo hit at 11:44, which damaged her propellers and rudder, leaving her barely maneuverable. More torpedoes followed, more bombs rained down. The Repulse, more agile, dodged 19 torpedoes in the initial attacks, her captain expertly conning the ship through the forest of underwater missiles. But eventually, the sheer number of attackers overwhelmed the British defenses. Torpedo after torpedo struck home. Both ships were doomed. The Prince of Wales went down at 13:20, taking 327 men with her, including Admiral Phillips. The Repulse followed at 13:33, another 513 men lost to the sea. In less than 2.5 hours, the Betty and its sister aircraft had accomplished what many had thought impossible. They had sunk modern capital ships at sea through air power alone. The age of the battleship was over. The age of air power had arrived. For the Betty bomber and its crews, this was the ultimate validation. They had achieved what generations of naval theorists had only dreamed of. They had proven that land-based aircraft could challenge and defeat the most powerful naval forces. Admiral Yamamoto's strategic vision had been vindicated. The Betty had performed magnificently, its range allowing it to reach the British ships far from Japanese bases, its speed and altitude protecting it from the relatively light anti-aircraft fire, its torpedoes proving devastatingly effective. Japanese propaganda made much of the victory. The crews who had participated in the attack were celebrated as heroes. The Betty bomber was hailed as a war-winning weapon, an unstoppable force that could strike anywhere, anytime. Plans were already being drawn for even more ambitious operations. The Gilbert Islands, the Solomons, New Guinea, Australia itself, all seemed within reach of the Betty's extraordinary range. But there was a problem, a crack in the foundation of Japanese air power that would only become apparent later. The British ships, while they had fired continuously, had been caught in the worst possible circumstances. They had no air cover. They were operating in waters controlled by the enemy. Their anti-aircraft armament, while heavy, was designed for a different era, not yet optimized for the kind of high-speed, high-altitude attacks that the Japanese were mounting. And critically, most of the British gunners had never before engaged aircraft in combat. They were learning on the job, and they were learning too late. The Betty had not yet faced determined, experienced opposition. It had not yet encountered the concentrated, coordinated fighter defenses that the Americans were already beginning to develop. It had not yet tried to attack a well-defended American carrier task force with experienced pilots and modern fighters. When those encounters came, the Betty's fatal vulnerability would be revealed in the most brutal way possible. The first hint of what was coming occurred on February 20th, 1942, less than 2.5 months after the triumphant sinking of the British battleships. The target was the American aircraft carrier USS Lexington and its task force, which had been detected by Japanese reconnaissance aircraft while operating in the waters northeast of New Guinea. 17. Betty bombers from the 4th Air Group were dispatched to attack the American ships, flying from Rabaul, the Japanese stronghold that would become the center of their operations in the South Pacific. The mission should have been another demonstration of the Betty's capabilities, another chapter in the story of Japanese air superiority in the Pacific. But this time, the Bettys were flying without fighter escort. The A6M0 units available at Rabaul lacked the external fuel tanks needed for such a long-range mission. The bombers were on their own, relying on their speed, their altitude, and their defensive armament to protect them. The Lexington's radar detected the incoming raid well before the Japanese aircraft arrived. American F-4F Wildcat fighters were launched and vectored toward the threat. When the Bettys arrived, expecting to face the limited, poorly coordinated defenses they had encountered over the British ships, they instead found themselves confronted by experienced American naval aviators who had been training for exactly this kind of engagement, who knew their aircraft's capabilities and limitations, who had developed tactics specifically for dealing with Japanese bombers. What followed was a massacre. The American Wildcats tore into the formation of unescorted Bettys with devastating effectiveness. The Japanese defensive gunners fired back furiously, the 20-millimeter tail cannon claiming at least one Wildcat. But it wasn't enough. The Betty's lack of armor and unprotected fuel tanks turned each bomber into a vulnerable target. A solid burst of .50 caliber machine gun fire would punch through the thin aluminum skin, tear into the fuel-filled wings, and within seconds the aircraft would be trailing smoke and flame. 15 of the 17 Bettys were shot down. 15. Only 2 aircraft managed to make it back to Rabaul, both damaged. It was a catastrophic loss rate, the kind of attrition that no Air Force could sustain for long. The crews who survived brought back sobering reports of the battle, of how quickly their aircraft caught fire when hit, of how the fuel seemed to explode at the slightest spark, of how helpless they felt as their comrades' aircraft disintegrated around them. One of those aircraft shot down demonstrated in a terrifying way what combat in the Betty had become. Lieutenant Commander Ito's bomber, its wing tanks ruptured and leaking fuel, took a burst of fire from Lieutenant Edward Butch O'Hare that completely shot one engine off its mounts. The crippled Betty, trailing fire and fuel vapor, began a deliberate turn toward the Lexington. Ito, seeing no possibility of survival, had decided to take as many Americans with him as he could, attempting what would later be called a kamikaze attack, though the formal kamikaze program wouldn't begin for another 2.5 years. The Betty was riddled by anti-aircraft fire as it approached the carrier and crashed into the sea short of its target. But the incident was a harbinger of things to come, a demonstration of what happened when Betty crews found themselves in an impossible situation with nowhere to go and no hope of survival. The disaster over the Lexington should have prompted an immediate reassessment of the Betty's vulnerability. The loss rate was unsustainable, but several factors prevented the kind of wholesale redesign that might have saved countless Japanese airmen's lives. First, the Betty had already proven itself in successful operations against less capable opposition. The attack on the British ships, the raids on China, the Philippines operations, all had been successful. The Lexington attack could be dismissed as an anomaly, bad luck or poor tactics, a mission that should never have been flown without fighter escort. Second, there was a cultural element at play. Japanese military culture, influenced by centuries of samurai tradition, emphasized offensive spirit over defensive preparation. The idea of sacrificing range and offensive capability for protection struck many officers as defeatist, as contrary to the aggressive spirit that they believed won battles. A warrior was supposed to strike first and strike hard, not cower behind armor. This wasn't just rhetoric. It was a deeply held belief that influenced design decisions across Japanese aviation, from the Zero fighter to the Betty bomber. Third, and perhaps most importantly, there were practical constraints. Japan's aviation industry was already operating at capacity, producing aircraft as fast as possible to meet the demands of the expanding war. Redesigning the Betty to incorporate self-sealing fuel tanks would have required retooling production lines, developing new manufacturing processes, training workers in new techniques, all while production continued. The delays would have been significant. The loss of production capacity would have been severe. And for what? To fix a problem that had only manifested once in circumstances that should have been avoidable. So production continued. Betty bombers continued to roll off the assembly lines at Mitsubishi's factories, and they continued to fly missions across the length and breadth of the Pacific theater. They attacked targets in New Guinea, in the Solomon Islands, in the Aleutians. They struck at Allied shipping, at airfields, at ground installations, and they continued to burn. American pilots quickly learned that the Betty was extraordinarily vulnerable to gunfire. The aircraft's distinctive cigar shape made it easy to identify, and experienced pilots developed tactics specifically for engaging it. The key was to attack from angles that allowed your guns to rake the wings, where the fuel tanks were located. A short burst into the wing root, where the fuel tanks were fullest and closest to the fuselage, would almost guarantee a catastrophic fuel fire. The Betty would either explode immediately or, more commonly, begin trailing smoke and flame, the fire spreading rapidly through the fuel-soaked wing structure until the wing itself failed and the aircraft broke apart. One American pilot's combat report captured the typical engagement. Closed to 100 yards and fired a 3-second burst into the wing root. Saw strikes immediately, followed by a flash of fire. The Betty's wing separated from the fuselage almost instantly, and the aircraft tumbled out of control, leaving a trail of burning fuel. Another pilot recalled, "You didn't need to hit them much. If you got any strikes on the wings, they'd start burning. It was almost too easy." You felt bad for the crews. They had to know they were flying around in a flying bomb. The nickname "one-shot lighter" became universal among American fighter pilots. Japanese crews, meanwhile, developed their own gallows humor about the aircraft they flew. Officially, the nickname "Hamaki" referred to the Betty's cigar shape. But airmen knew it had another meaning, a darker one, referring to the aircraft's tendency to burn like a cigar when hit. Some crews, with grim fatalism, referred to it as the Type 1 lighter, playing on its official designation as the Type 1 attack bomber, acknowledging that it could be lit on fire with a single bullet, a single tracer round. Yet despite this known vulnerability, Betty crews continued to fly missions, continued to face enemy fighters, continued to attack heavily defended targets. Partly, this was because they had no choice. The Imperial Japanese Navy needed the Betty's range. No other aircraft in the Japanese inventory could reach the targets that needed to be struck. Partly, it was because crews believed in the offensive spirit that had been drilled into them since basic training, the belief that aggressive attack was the path to victory. And partly, it was because when the Betty was successful, when it did reach its target and deliver its payload, it could be devastatingly effective. The G4M remained the backbone of Japanese land-based naval aviation throughout 1942 and into 1943. These bombers participated in virtually every major campaign in the Pacific. They attacked Port Moresby in New Guinea repeatedly. They struck at Allied shipping in the Solomon Islands. They raided targets in Australia. They supported the Japanese offensives at Guadalcanal and the Central Pacific. And with each mission, more Bettys failed to return, more crews were lost, more evidence accumulated of the aircraft's fatal flaw. The technical air intelligence units were keeping careful records. Every downed Betty was examined. Every combat report was analyzed. Every piece of intelligence was collated and distributed. The TAIU, originally formed as a joint effort between the U.S. Army Air Forces, U.S. Navy, Royal Australian Air Force, and Royal Navy, had established its headquarters at Eagle Farm Air Base in Brisbane, Australia, in November 1942. Operating out of Hangar 7, teams of intelligence officers and technical experts worked tirelessly to understand Japanese aircraft, to find their weaknesses, to develop the tactics and weapons that would defeat them. Crashed and captured aircraft were located, identified, and evaluated, often in or near the front lines. Aircraft that weren't too badly damaged were recovered and rebuilt for test flights. The process was systematic and thorough. Crashed enemy aircraft reports were compiled, detailing every aspect of the aircraft, from engine specifications to armament to structural details. Production data was carefully noted, giving intelligence analysts insights into the state of the Japanese war economy. The TAIU teams faced numerous challenges. One of the biggest was souvenir hunters. American troops had a maddening habit of stripping parts from downed Japanese aircraft before the intelligence teams could arrive. Instruments would be missing, data plates removed. Even critical components like gun sights and weapons would disappear, carried off as trophies. Repeated orders were issued against this practice, but with limited success. The lure of having a piece of an enemy aircraft to send home or keep as a memento was too strong for many soldiers to resist. Another challenge was simply reaching the crashed aircraft. Many went down in the ocean and were lost forever. Those that crashed on land often ended up in remote, inaccessible locations. In one famous case, a newly developed Yokosuka D4Y Judy dive bomber crashed 6 miles inland on a 1,500-foot hill on Santa Isabel Island. The TAIU team had to recruit local men to cut a trail through the jungle with machetes, then construct a cradle woven from tree bark to carry the engine out of the jungle. The dedication and resourcefulness of these teams would pay enormous dividends in the intelligence they gathered. By early 1943, the TAIU had built up an impressive database of information about Japanese aircraft. They understood the capabilities and limitations of the Zero fighter, having rebuilt a captured example from parts of 5 different aircraft and test-flown it against a Spitfire fee. They knew the performance characteristics of the Oscar fighter, having conducted extensive flight tests, and they had examined numerous Betty bombers in various states of damage, piecing together the story of this remarkable but fatally flawed aircraft. But it wasn't until they got their hands on a relatively intact Betty, one that had been forced down or captured before being completely destroyed, that they could conduct the kind of detailed examination that would reveal the full extent of the design compromise that Kiro Honjo had been forced to make back in 1938. The examination of a captured Betty bomber was a revelation to American engineers and intelligence officers, even those who had been studying Japanese aircraft for months. They had expected to find technological sophistication, perhaps some innovative solutions to the challenges of long-range bomber design. What they found instead was an aircraft that represented a fundamentally different design philosophy, one that made choices that no American or Allied engineer would have been authorized to make. The Betty's construction was, in many ways, excellent. The airframe was well engineered, the fuselage cleverly designed in 2 halves for ease of production. The engines, the Mitsubishi Kase 14-cylinder radials, were powerful and relatively reliable. The aerodynamics were clean, contributing to the aircraft's good speed and range. From a purely engineering standpoint, there was much to admire about the Betty's design. But then the examination teams began cutting into the wings, tracing the fuel system, mapping out how the aircraft stored and managed the enormous fuel load that gave it its extraordinary range. That's when the magnitude of the vulnerability became clear. "There's no self-sealing material here at all," one engineer reported, his voice carrying a note of disbelief. "The fuel tanks are just the wing structure itself. If you puncture this, fuel pours out freely." Another engineer, more senior, examined the wing structure carefully, looking for something, anything, that might provide protection. No rubber bladders, no armor, not even a carbon dioxide fire suppression system. This aircraft has absolutely no fuel tank protection of any kind. The team worked systematically, moving from wing to wing, from one fuel bay to the next, documenting every detail. They measured wall thicknesses, examined rivet patterns, traced fuel lines, and confirmed the absence of any secondary containment. There were no rubberized layers hidden beneath the skin, no emergency shutoff valves that could isolate punctured sections, no fire suppression system to flood the tanks with inert gas. The conclusion was unavoidable. The Betty's fuel tanks were completely exposed. In American and British aircraft, self-sealing fuel tanks were considered non-negotiable. Even if a tank was punctured, layers of untreated rubber would swell on contact with fuel, sealing the hole and preventing catastrophic leakage. Armor plate protected critical sections. Firewalls separated engines from fuel. Crew survival was a design requirement. In the Betty, none of that existed. One intelligence officer summarized the findings in a report that would be circulated to fighter squadrons across the Pacific. The G4M bomber achieves its exceptional range by sacrificing all fuel tank protection. Any penetration of the wing structure is likely to result in immediate fuel leakage and ignition. The aircraft is extremely vulnerable to incendiary and armor-piercing fire. This wasn't merely an academic observation. It was a tactical revelation. American pilots were briefed immediately. Fighter intelligence officers began updating combat instructions. The advice was simple and brutally effective. Aim for the wings. Ignore the fuselage. Ignore the engines. A short burst into the wing root would do more damage than prolonged fire anywhere else. The results were immediate and devastating. As American air power grew stronger in 1943 and 1944, the Betty's losses mounted at an unsustainable rate. Over Guadalcanal, over New Guinea, over the Solomon Islands, formations of Bettys were shredded by increasingly experienced Allied fighter pilots flying faster, better-armed aircraft. What had once been Japan's greatest strength, range, became irrelevant in a sky dominated by American fighters and radar-directed interceptions. Japanese attempts to mitigate the problem came too late and achieved too little. Later variants of the G4M added limited armor and rudimentary self-sealing tanks, but these changes reduced range and performance without fully solving the vulnerability. By then, Allied pilots had already mastered the tactics needed to destroy the aircraft efficiently. For Japanese crews, flying the Betty became an exercise in fatalism. Veterans knew the aircraft's reputation. They knew that one hit could mean instant death. Yet missions continued, often flown without adequate fighter escort, often against overwhelming opposition. Losses were accepted as the price of duty. By the end of the war, more than half of all G4M bombers built had been destroyed, along with thousands of trained aircrew Japan could not replace. Standing over the cut-open wing of that captured Betty in 1943, the American engineers finally understood why. The Betty was not a poorly designed aircraft. It was a perfectly designed aircraft for the wrong war. It reflected a strategic assumption that speed and range would outweigh survivability. That offensive reach mattered more than crew protection. That the enemy would be unprepared, disorganized, and technologically inferior. Once those assumptions collapsed, the aircraft's fate was sealed. The unprotected fuel tanks were not an oversight. They were a conscious choice. And in the skies of the Pacific, that choice burned again and again, until the truth was written in fire across the wings of the flying Zippo. That is why, when American pilots examined a captured Betty bomber, they weren't just confused. They were looking at the physical embodiment of how a nation had gambled everything on range and lost the moment the enemy learned where to aim.